Hi, everybody. Today, I'd like to talk to you a little bit about why I feel CAD is an essential part of being a electronics uh, person, and this is a little bit nebulous because what is an electronics person? Okay, is that somebody who simply works on electronics, and so maybe uh, troubleshoots and repairs circuit boards? Is it somebody who designs circuit boards? Is it somebody who works in sales in the electronics department? And you have quite a few different opportunities for people in the electronics field to branch out and do something. And so I'm sure a lot of people sit there in CAD class and wonder, why do I need to learn CAD? And it's pretty straightforward, and it goes for the electromechanical people as well. Now, in electromechanical, you've got this clear set path that you're going to follow. I'm going to finish my schooling. I'm going to get a job in a factory somewhere, and I'm going to work there forever. That's fantastic. Uh, so you need CAD as well. And the reason, let's start with the easy one. The electromechanical people will need CAD because you need to be able to produce drawings, and that's fairly straightforward. And so 2D CAD is exactly up your alley. The difference being when it comes to 3D is that you can actually save time and money by being able to assemble your components in 3D space, and so that's fantastic. Uh, that this way, when you're ready to go at creating your panels and your boxes in real life, you already know how it's going to fit together, and so that's the real advantage of working in 3D for the electromechanical. Now, that said, there's a second aspect. And so once you start designing robots and conveyor systems, there's an opportunity for you to create CAD that will be manufactured or at least passed on to a mechanical engineer that will get drawings approved for production in a factory. And so you may have an idea for a gripper finger to put into automation that would make this a much better system. And so having this CAD available is fantastic. On the same note, there are an ample number of jobs right now for electromechanical people who can actually draft even in 2D. If you can imagine how many drawings are out there right now, and the new standard is to have them all in CAD. So you have the opportunity to jump into that role and start creating CAD drawings. And so that's fantastic. Now, the electromechanical people, you you're set, right? You've got your path. For the electronics guys, you're probably sitting there scratching your head, wondering, why do I need to draw a schematic in AutoCAD? And the answer is, it's good practice. Okay. Um, the real advantageous thing for CAD people uh, when it comes to electronics is to be able to take an electronics design that you maybe used an EAD software like Proteus and integrate it into a physical model. And so you can take an idea of a component and master the electronics around it, and then embed it inside some part. And once you have this CAD, you can send it out and get it FDM printed. You can have it machined. You can have it actually go into production. And I've had a lot of experience over the years of making prototypes, making things that, came from here, and being able to draw it in CAD, show it to people, get their approval, or possibly just go straight into manufacturing of a prototype. And so this is something that you really have a great opportunity at this point to grab a hold of. And there's absolutely no reason that you can't make a drawing and run down to your library and get it printed for cheap and then show somebody. Okay? And the fact that you're gaining the knowledge to do the electronics, now this isn't just a static widget. You can actually make something and really get into something called the maker community, where you have like-minded people to share your ideas with. And it's a fantastic way to explore new concepts. The best way to excel in the electronics field is to make it your hobby. Okay? Now, by hobby, I don't necessarily mean just sit down and play games. Okay? I'm talking about find something that you are interested in. If it's making your own power supply, start to research it. If you're really into music, fantastic. Make something. Okay? There are numerous designs that are out there that you can use to explore and use that as a starting point, not the end point, but a starting point. Oh, look at, I found this. This looks neat. I can create some fancy wave with this. What happens? I want to try changing this. I want to try changing that. And it's a great way to move forward in the electronics. The fact that you can then take that and embed it inside a box that you've designed makes it even more personalized. And the third piece to this, the trifecta, if you will, is to have at least a rudimentary knowledge in programming. Whether it's a microprocessor or microcontroller, whether it's a small ARM-based or PIC-based chip on a board, or it's a single board computer like a Raspberry Pi or a full PC, being able to interface with these electronics and ergo your mechanical model makes this truly unique. And once you can kind of complete the little triangle of mechanical, electronics, and software, you are truly a Renaissance man. You can do anything. Anything you can imagine, you'll be able to make. And this is what I strive to show you guys in this class, CAD 1134 and CAD 1133, where we actually get into using Proteus as a full-on suite, and we actually create a circuit board, and we actually simulate, and we start to look at how to source parts. And you can take this right to the limit. And being able to work in the maker community gives you such a big advantage when it comes to your resume. Because being able to show up with a box full of parts and projects that you've made, or possibly creating a web page that you can point at and say, these are all the projects that I did. You see this? So I created this. It came from my head. Because the one thing that seems to be missing with a lot of people's understanding of the maker community is that they can just go and take an Adreno and put a shield on it, and this is a maker project. This is an introductory thing. This is how we get started. But to truly get into making something unique, you need to be able to sit down, think it through, do the design work, and then prototype it. And that's the real center of the triangle, is the ability not to just design it or think about it, but to physically do it. So I've had some projects over the past. Here's one. This was actually a device that goes into a boat, and we sent this all the way to England for the Olympics. There's no electronics in it, so it's maybe not that interesting to you guys. But, you know, it actually worked, and we actually sent it into the Olympics. And a great story about it. You know, it was one of those things that we had an idea, made a quick prototype, we tested it, we saw that the physics actually worked, And then we started to refine it. And using the CAD, we were able to use something called CFD, or computational fluid dynamics, to optimize our design. And so we'd make modifications to the virtual model, run it. It would actually run on my PC overnight. I would take a look at the results in the morning, set up a second test, and let it run all day while I was at work. And I'd come home and then compile it and do this over and over and over again until I got the results that I really wanted. And then we prototyped it. We did some physical testing and we made some modifications. We made another prototype. And then, we did field trials, and fantastic. Everybody loved it, and off we went. And the funny thing was that we were planning on making this out of steel or aluminum, and we just ran out of time. The Olympics were right around the corner, and so we thought, okay, well, the FDM is working well enough. Let's send some samples with the athlete, and it's only going to be for a couple of weeks. We're not too worried about the longevity. And as it turns out, it was fortuitous that we sent the FDM model, because it turns out that a rope got tangled around the device. And when the powerboat took off to drag the sailboat, it sheared this device off at the waterline. And so if it had have been steel, we could have done a lot of damage to the boat. But instead, through some clever design work, 4 screws later, we were able to simply replace it, swap it out, and off we went. And so that's a little bit lucky, but at the end of the day, we said, hey, maybe we don't want to make this out of steel or aluminum, maybe plastic. Resin is the right material to use in the first place. And so, unfortunately, this project, it's still sitting on a shelf, may or may not ever move, but, a lot of hard work went into it, and that's the way that goes. Other things that you can make. So in this case, I have a keypad that I wanted to make. And so this was something that I just needed. And so, it's fast and easy for me to quickly prototype that up and send it out and have it made. These days, the stuff that I work on is it's relatively cheap to make a circuit board these days. And so these 100 by 100 millimeter circuit boards will run you with shipping somewhere in about the $30 or $40 to get 10 of them. And so, yeah, depending on what you value your time at, it's definitely something to consider. To this end, I've made this little development board and just simply purchased a bunch of them with no real end goal. And the reason being, I often need to prototype something up and have a board that I won't see back. And so I don't want to make a breadboard and do all that. Perhaps I don't have time for a custom board. So I made these up with these nice little connectors. So this is something you can do. Some things you can't actually prototype with conventional means. For example, this circuit board, I have basically, it's like a rain sensor on the back, and we couldn't actually simulate this. So we had to physically test it, and we could get so far with handmade samples, and then you just send it out and you get it made. And this is really, really inexpensive. And of course, being able to program brings it all together. And so if you can write your own program, you don't need to be the best programmer, but at least get to the point where you can at least be able to address the sensors that you want to use, be able to do some processing, and define whether or not your board is working. You can then pass it on to others who can maybe do a much better job at programming it. But the idea is that you want to be able to get down to bare metal and be able to make your widget work. And these really can be anything that you imagine. And by that, I mean, it could be something as small as a little servo driven something, or it could be a completely automated facility. I've had students who were approached by family and friends who wanted them to automate a barn. I've had people who have had ideas for putting a satellite into space. I've had students who just have an idea and don't know how to move forward. And so what I really want you to do is to think while you're working through the CAD classes, working through your introductory classes, of what you can apply this to. Because I'm deadly serious that if you make this your hobby, if you make this something that you're truly interested in, that you go home with ideas, right? You wake up in the middle of the night and you're like, oh, yeah, if I did this with that, then I could, oh yeah. And then if I make this CAD thing and then I can get it printed and then we'll put it together and I can program it like this. Ooh. All of a sudden you've got it. You've got an inventor's mind. And that's something that you can truly use on your resume. All right. I hope this was interesting and maybe a little bit encouraging. I really want each and every one of you to excel. The opportunities that are being presented to you are yours for the taking. And so please grasp it. Grab that ring and run with it. All right. If you like this video, please give it a thumbs up. If you didn't, thumbs down's A-OK. Some constructive criticism only helps me, and I appreciate it. And if you'd like to be kept up to date when I post any of these videos, do subscribe. All right. Thanks, and have a great day. Bye now.